Welcome everybody to Chapter 7. This is 7.1, right triangle trig. You probably remember some of these things from your great days in geometry. SOHCAHTOA. We're going to use all these trig ratios and inverse trig ratios to calculate some problems and some real life problems, and all of you engineers out there. So here's your launch, your intro. Do you remember SOHCAHTOA? Sine, cosine, and tangent. So remember, capital letters are the angles. If this is angle A, lowercase a is opposite. This is called adjacent, where lowercase b is. And lowercase c is always called the hypotenuse. So you can see sine is opposite over hypotenuse, in this case a over c. Ka for cosine, adjacent over hypotenuse. And toa for tangent. And we can go from either of the acute angles in this right triangle. We can go from B, which will change things up a little bit. But hopefully you remember a little SOHCAHTOA. Here is your book's definition of all of the parts of the right triangle. They've got SOHCAHTOA written down here again. You can check these out in your book. But again, I hope you are remembering these from geometry days. Here's just a little language connection. Sine has a curious history from Sanskrit. You can read a little bit about that. I just like you all to know that mathematics is worldwide, used everywhere, and we all can take some pride in knowing that we have some connection to our different types of math. All right, here's a problem we can use to solve any parts of the right triangle. Remember, SOHCAHTOA works for right triangles. So in this case, I want to find the hypotenuse, x. So I know I do not want to use SOHCAHTOA. Tangent is out. If I go from angle B and I label this side, it would be the adjacent side. So now that means I'm going to use the cosine function. Okay? And if I set up an equation, if I do the cosine of angle B, which is 43 degrees, it's going to equal 20 divided by x. So cosine is adjacent over hypotenuse. I put the 20 on top and the hypotenuse x on the bottom. To solve this, you would multiply both sides by x, and you'd get x times cosine of 43 degrees equals 20. And I think you can see how to solve this for x. Divide both sides by the cosine of 43 degrees. Make sure your calculator is in degree mode, and typing all of that in, you can reveal the answer over here. You should get about 27.35. And if you think about it, this length looks a little bit longer than this angle, and x is obviously going to be the longest side because that's our hypotenuse side. Here are just some simple problems to check by using your calculator, typing in the sign of each. I will grab my calculator here so you can see how to type them in, and make sure you are in degree mode. We'll give this a second. So if you go to mode on your calculator, the default is radians, and you'll be learning about radians a little bit later. So the mode button is right there. You can see I am in radians. I'm now highlighting float, radian. So I'm going to go over to degree, and I'm going to hit enter to make sure I'm in degree. Now I'm going to try the sine of 23 degrees, and there's your answer. So for this first problem, if you round it to 3 decimal places, you are at 0.391. And if I grab my calculator for the tangent of 33, here's my tan button, 33 degrees, and I'm at 0.649. And then I've got cosine of 41. And you can find all that in there too. And here's cosine 41, approximately 0.755. Just clarifying and making sure you know how to use that calculator. Here's a little investigation from your book. The two acute angles of a right triangle add up to 90. If you think about it, the right triangle is 90. That leaves 90 more because all triangles add up to 180. What can you say about the values of sine x, cosine x, sine 90 minus x, cosine 90 minus x? This is something you could explore with your calculator. You could put a value in here for x. Let's say, I'll make it simple, 30 degrees, and this one is 60 degrees. You should notice a few things. If we label the sides A, B, and C, this would be C. We'll go A and B. This would be lowercase c, lowercase a. So the sine of 30 degrees is going to equal B over C. Hopefully you notice maybe something about the cosine of 60 degrees. Adjacent over hypotenuse is going to be B over C. So doing a little exploring, you're going to come up with some simple things that happen. And you could type these into your calculator, but the sine of x is the same as cosine of 90 minus x, and same with cosine x and sine of 90 minus x. There's a way to find the missing angle as well. You're going to use the inverse sine function on your calculator. So for this problem, if I did not know this and wanted to find x degrees, one of the ways I could solve for x would to say opposite over hypotenuse. That is just one way to do it. So to solve for x, you have to take the inverse sine of 3/5. And you should get about 37 degrees. I'm going to grab my calculator again and show you how to type that in. We can clear these out by going to quit. We can go second sine 3/5. And there's your 36.87 degrees. You're supposed to find the inverse cosine of 3/5. So grab that calculator again. Second cosine 3/5, and you've got 53 degrees. Probably going to notice 53 and 37 add up to 90 degrees. Another way to look at that relationship between sine and cosine. Here is a word problem. Application problems are everybody's favorites in Honors Algebra 2. Wow, we're going to have two hikers leaving their campsite. Emily's going east, Savannah's going south. Notice the names start with E and S. After Savannah gets to her destination, she looks toward Emily. What's the measure between the paths? So we're going to draw a diagram. Make it look like this. Emily went to the east, Savannah went to the south. And we want to find the measure of angle S. So I'm in my right triangle. I do not know the hypotenuse, so I have to use tangent. If you think about SOHCAHTOA, sine and cosine both use hypotenuse. We don't have any information on the hypotenuse. So if I'm going from angle S, I could say the tangent of angle S is equal to opposite over adjacent, which is 2.85 over 6.03. Now you're going to learn that when you find an angle, a missing angle, you're always going to do the inverse trig function. And there you have it. You could type that into your calculator and make sure that you get 25 degrees. Here's the same problem. And this is a famous street in San Francisco. And how could you find the height of this triangle using trig functions? We'll give you a minute to think about it, but if I want to find this height, I've got the hypotenuse, I've got the angle down here. This would be opposite. Sine would be opposite over hypotenuse. So I could say the sine of 20.8 degrees equals my question mark over a quarter mile. So my answer is going to be in miles. If you multiply both sides by 1/4, you're going to get your answer to your question mark. And grab the calculator and clear this out so you can see a little bit better. Second quit. There we go. 1/4. 1 divided by 4, you could use 0.25 times the sine, what was it, 20.8? It was 20.8 degrees. And you're going to get 0.08877. So I'm going to go 0.089. And that's miles. If I want to change that into feet, I could multiply that by 5280. I'll bet you all remember there's 5,280 feet in a mile. Might give you an answer that means a little bit more to you. We're at almost 469 feet. Those of you that love yards, you could divide that by 3. You're at about 156 yards, which is about a football field and a half. That would be that height. All right, here is some old word problems that you can do to give yourself some more practice. Try to make a little bit better picture here. You've got a ramp on a porch, 24 inches high. What angle do you want to find? So again, you're looking at SOHCAHTOA as your choices. So if you label each side, this is the hypotenuse with no information. So I do not want sine or cosine. I want the tangent again. Opposite is 24 over x. My answer will be in inches. Those two little hash marks there stand for inches. If you want to label the sides, this is the opposite side. This is the adjacent side from this angle. So to solve this problem, I multiply both sides by x. I have x times the tangent of theta equals 24. I goofed up. We're going to have to do the inverse tangent of 24 divided by x. We have too many variables here. We have two unknowns. So what angle will the ramp make with the ground? 24 inches. The ramp needs a slope between 1/16 and 1/20. We're going to have to come back to that one. What are trig ratios? What's the difference? Here are some problems to practice. We'll give you a minute to practice them. Here are a couple of answers. When you divide sine by cosine, you get tangent. And if you think about it, sine over cosine would be opposite over hypotenuse over adjacent over hypotenuse. And to divide two fractions, my oh my, flip the second and multiply. So we're going to flip that. And we're going to go O over H for opposite hypotenuse. We're going to flip that to H over A. H's cancel, and you have O over A. And that's tangent. That's opposite over adjacent. Here's some more skills to refresh your memory on 30, 60, 90s. Hopefully you remember what they look like. 30, 60, 90s, you do not need your calculator. The sides go x, 2 times x, x times the square root of 3. So in this problem, this is nice and easy. X is 4. That means 2x is 8. That means x times the square root of 3 is 4 times the square root of 3. So in this case, 2x is equal to your a, and b is your x root of 3. Another refresher from geometry. Here is your right triangle, 45, 45, 90 right triangle. The ratios are in 1, 1, square root of 2, or I like to call them x, x, x times the square root of 2. The longest side is the hypotenuse. This is also isosceles because you have 2 equal sides. So if this is a isosceles, that means these are 45. Do you remember that these little tick marks mean they're the same sides? So this would be x, this would be x, and this would be x times the square root of 2. So x equals 9, x equals 9, x times the square root of 2 would be 9 times the square root of 2. In this case, B is your 9 times the square root of 2. And your A, whoops, is 9. Oh, this is a fun problem to work your way around and try to see what kind of a triangle you have. If you can check this one out, it sure looks like you have x and 2 times x. So this would be x root 3. You can remember 30, 60, 90s. Go x on the smallest side, 2 times x on the hypotenuse, and x root 3. So letter A would be square root of 5 times the square root of 3, which is the square root of 15. If you go to letter B over here now on this next triangle, we'll make it green so you can kind of pick it out. We've got 2 root 5 and 2 root 10. That means that this side was multiplied by the square root of 2. It means these two sides are the same again. So B is going to be 2 root 5. These two sides are equal. This is a 45 and a 45. And you could check it out. The hypotenuse would be 2 root 5 root 2. Because you've got x, x, x root 2. You also could do the Pythagorean theorem on this. A squared plus b squared equals c squared. You could do that on the last one too. I'm going to make this last triangle. And I'm going to do the Pythagorean theorem just for fun. The hypotenuse is 2 root 10. So you know the square root of 30 squared plus c squared equals 2 root 10 squared. When you square a square root, you're going to get 30. When you square this, you've got 2 root 10 times 2 root 10 is going to be 4 times 10. So you're going to have 30 plus c squared equals 40. Subtract the 30. C squared is 10. So what's c? The square root of 10. And those would be your answers to that problem. And that is going to wrap up Chapter 7 to start with. I hope you enjoyed our video and remember all of these great things from Chapter 7 coming from geometry. Thanks for listening, and that's going to end my video.